for entire the fraternity electric vehicle conceptualized about 3 years back. Thanks to our very good friends, mentors, supporting team from General Motor Technical Center of India. Of course, I would like to thank here one Dr. Vijayakantan Damodaran, who's been instrumental in creating this aura for us. Of course, fully supported, mentored, coached by Mr. Brian, and of course now in the hands of Dr. Shivkumar, and host of others who have been part of this journey within the TCI team as well as outside various partners. Extra so far, despite this pandemic, thanks to the volunteers' enthusiasm and commitment from all the industries, we are able to keep that momentum going. And fortunately, we could get close to about 10 teams participating for the forthcoming event. So that way, we are very, very happy, thankful to all the supporters, volunteers, and well-wishers to take this journey so far. With this mind, I would like to again also thank the entire team for part of this interesting journey. So this is going to be a game changer for all the students in India. We wanted to encourage more and more students to participate and ensure that this becomes, just to give you a few, put that actually I'm in indoor in Pithampur. Behind me, you can see the Matrax track photos. We are here to witness this MBAHA event. And I hope in a couple of years from now, we will reach that stage of Baha. I'm very confident that this will happen with that kind of deep commitment from the volunteers, faculty advisors, students, and supporting companies to reach this stage. With this, I'd like to again welcome and I wish you all the good luck for this REEV virtuals. Over to you, Som. Thank you so much. Som, maybe Girish.
Som, you're on mute.
Thank you, sir. Thank you so much for your motivating words to students. Now, request Mr. Girish Ramaswamy, the Vice Chairman of the India Bangalore section, to speak a few words.
Thanks, Som. Overall, I think your voice is not clearly audible. Maybe you can check in the background. Again, good morning to each and everyone on the call. As you know, Muni explained, I just want to take his words forward. REEV, as such, is becoming, or we want to make it a kind of flagship event for our Bangalore section. As Muni explained, pandemic, really has taught us a lot of lessons. And we need to take at the end of the day the positives out of all the struggling what we did in the last 2.5 years. Hopefully the situation where we are today, I think we should be I'm hopeful that will continue, as well as we'll be able to make our events in the physical form like how we used to do in the yesteryears. So with this, I think also REEV, coming back to the REEV itself, I see it as a kind of futuristic event. Why I say, because when you go back 20-25 years ago, normally any product that would have been developed, especially in automotive, when you see, it was purely a kind of branch specific. Mechanical engineer was known for automotive, development of cars or engines. So of late, with the introduction of electronics inside the car or any two-wheeler for that matter, or even for trucks, today we see within one branch, it's impossible to make any kind of a product. This is the stage where we are in today. So if we have to make any vehicle or an engine or any product for that matter within a mobility community, we need to have cross branch, collaboration. So on the same basis, REEV is also a similar event where you could see combination of branches either from computer science or mechanical or electronics and electrical. All engineers come together to design a product, and also at the end I think they see that it runs on the road, which is the final aim of any engineers who are designing developing a product for automotive. So I take this opportunity to all the students to learn and excel in those areas which will be the future of automotive technology. And also all the best to all the students, and I wish very soon, as Muni said, we are today only 10, we want to cross 100 very soon with the success of our event today. So thank you. Over to you, Som.
Thank you so much, sir, for your kind words. I'm sure students will be motivated to perform well during this workshop for today. Sir, next we have Venkat K. Venkat Raj, the Deputy Director General of SA India, to speak a few words. Over to you, sir. Thank you, sir. Thank you, sir. Are you able to hear us?
There seems to be a network problem in Venkis's this place.
Yeah, I don't see him on the list.
Yeah, he is not able to join. I just spoke to him.
Okay.
Yes, sir. Okay. So, sure, sir. So, next, we'll have Mr. Rakesh Bidri, the co-convener of REEV, to speak few words. Over to you.
Hey, thank you so much. I hope I'm audible. Again,
You're not that audible, Rakesh.
this is a great platform. Sorry, can you hear me, sir?
Yeah, now it's better. Continue.
Yeah, so again, as I said, this is definitely a great learning platform for the students. I would say at the right time. The reason is very simple. If you look at the industry, where the industry is going, right? All the technologies like EV and autonomous and shared mobility, it is at that inflection point where future is about all these new technologies, and REEV gives that exposure to the students so that when they join eminent organizations, right, they can do wonders, right? So I often see that this is the best time for any engineer to come and contribute into the industry, because being in industry for 20 years, I don't think I have all the answers for the problems which we are trying to solve, right? And students' creativity should definitely help, right? So, and you will hear after some time, we have one of the senior leaders from General Motors, Dr. Jayaraman Sukumar. We'll talk about electric vehicle technology, how one of the top global company in automotive industry or mobility industry, how they're looking at EV technology, right? Uh, uh, so that we will learn the importance of this technology, right? And I take this opportunity to thank all the guests who have joined on the call, Dr. Jayaraman Kumar, Mr. Muni, Mr. Girish, all the industry partners. So we are in presidency where all the industry partners are with us. because of technical glitch, we are not able to show everyone, but they are just sitting, around us, right? So I really appreciate their valuable time. And at the same time, I have one request to all the students to make is REEV is not a destination. REEV is a journey, right? So when you graduate through this REEV program, we would like you to continue to engage and participate in REEV and help the next level of students who would be participating, right? And we need to maintain this, I would say a great platform for many decades to come. And we definitely want this tree to become an oak tree and, nurture the young talent in the country. With that, I wish all the best to the students and the faculty members who are the backbone of helping students. Really thank them as well. With that, I hand over to Som. Thank you, Som.
Thank you, sir. Next, we have Mr. K. Venkatraj, Deputy Director General of SA India, to speak a few words. Over to you, sir.
Thank you, Som. Please confirm my audio video is okay.
Yes.
Okay, good. Good morning. Good morning, my dear students, respected professors, volunteers, SAE India staff members, Bangalore section team. We are witnessing a 2-year, or to be very precise, 3.5-year efforts. REEV, like our senior volunteer, Rakesh Bidre said, it's a journey. It all started with a simple thought in General Motors, and then we overlord to General Motors. We are here because of GM and volunteers like Rakesh Bidre, Moni Ratnam, Damodaran Subramanian, and many others. My dear students, I wanted to leave a couple of thoughts with you. In the 75th years of independence, SAE India celebrates 25 years. We are celebrating our Silver Jubilee. We have started off our journey with one student competition officially called Collegiate Design Series. And then we started adding one over another. At some point of time, we wanted to have a homegrown, India built, India conceived student competition. And I'm very, very proud to state that REEV is the first of its kind. It is conceived, designed, produced, mentored in India. In a way, it's a Make in India program. We are all indeed very proud to see the REEV at this stage. So I wanted to leave only 4 thoughts with you, my dear students. Your batch especially is going through a lot of challenges, struggles. COVID contributed many, but besides that, lack of labs. You have labs, but you are not allowed to get into the college for most part of your journey, correct? And there were struggles in identifying simple machines, simple mechanical engineering processes. But I think competitions like REEV has given you the learning. So the thought which I wanted to leave you with, number 1 is winning doesn't matter. Participation matters a lot. So if you have participated in REEV, you have learned a couple of things: how to machine a component, how to turn in, how to do welding, and then transporting, and many other things. These are the collection of experiences which will help you, in a way, industry ready. Number two, try to be a specialist in one field if you want to take notes. Industry needs specialists rather than a generalist. For example, I am wedded to powertrain. I am identifying myself as a powertrain guy, engine guy, electric guy, battery guy. So please identify one area which you will be specializing in the next couple of years. Could be 10 years, 15 years, etc. So speak to your heart, identify that, and go forward. So that's a number one. And number two is collaborate. The world is going to be very difficult, more challenges coming in. So I want you to please collaborate with your colleagues, with your principal, with your HOD, with your faculty advisors, SA India team, other volunteers, etc. So collaboration is a team. You may have to put down the three-letter word EGO down for a couple of years. It is difficult, but try to do that. Number three is SA India. Please visit our website. We have put in a lot of avenues for faculty advisors, for volunteers, for student members to learn, which is aligned with our theme, lifelong learning. For example, in the last 12 months, we have actually launched over 85 webinar/PDP, professional development program. Although many of them are specialized and meant for practicing mobility professionals, each student, each faculty advisor, each volunteer can benefit from this. So I'm just summing up the last three and then go to the final fourth one. We started off saying that we need to specialize in something. Gone are the days where you can say royal mech, correct? Now automobile engineering, mobility engineering, and you're expected to know Python programming, IoT, AI, and whatnot. So the world is expanding, and the number of electronics items is increasing in terms of percentage. An average car has about 40 to 45% of its content as electrical and electronics, which was not the case 2 decades earlier. So specialize, collaborate, leverage SA India, which takes us to the fourth and final thought, which I want to leave you with, is once you do this, then how can you contribute back to the society? It could be a simple invention which can save money or time or effort or something. So start thinking of this. The inventions doesn't come by everyday affair or going to office or something. The spark comes once in a while. You don't know when. We don't know when. So look for that spark of innovation. Specialize, collaborate, SA India, contribute. These are the four things I wanted to leave you with. And I'll spend 2 minutes on your SA India, and then I'll finish my welcome address. Your SA India has gone completely digital. You do have a quarterly magazine called Mobility Engineering, and there is no charge for publishing technical papers, except that it has to be vetted by a panel of experts, mobility experts. So please submit. It doesn't matter whether you're a student or a faculty advisor or HOD or a volunteer or senior or junior. As long as it is tech worthy, the panel of experts will be very happy to accommodate the tidbits or otherwise. So this is one. And the second thing is we are organizing 2 major events this year in Namma Bengaluru. June ಅಲ್ಲಿ ಏರೋಸ್ಪೇಸ್ ಕಾನ್ಫರೆನ್ಸ್ ಇದೆ, ಬಂದ್ಬಿಡಿ. ಆಮೇಲೆ October early, you have the SIMC, SAE India International Mobility Conference in its 10th edition. We are thinking of doing it with a grand celebration. We already have about 270 abstracts. So we are struggling to accommodate all the papers. We might be able to do 120 or 150 papers. So that talks about the grandeur of the mobility conference. These are two samples, but we continue to organize multiple technical programs for various stakeholders. And we are possibly coming back to normal. Our number of colleges or collegiate clubs have hit about 205. It used to be at one point 486. And we are getting good support. Our LinkedIn has hit about 43,900 followers, which is the first of its kind for any technical society. We are doing well. Please visit our website and you can learn more about SAE India. I take this opportunity to welcome the REEV aspirants, REEV teams, volunteers who have put in a lot of work to make this moment happen. Thank you so much, Moniratnam Garu, Rakesh Bedre, Damodaran Subramanian, and all the OC members and others. Thank you so much. And I'm sure, or rather, we promise a good time in REEV this year. Thank you. Jai Hind. Over to you, Somsekhar.
Thank you. Thank you.
Thank you, sir. Soms, over to you.
Thank you, Venki sir. Sir, next I request Mr. Vijay Ramakrishnan, the convener of REEV 2022, speak up. Over to you, sir.
Good morning, everyone. Can you hear me?
Yes. Perfect.
I want to start saying very good morning to all SAE dignitaries, SAE members, students, faculty, and people from Presidency University. I think a very good morning to you all. So this has been a very special day. So like the entire 8 months have culminated into the virtuals, and it has taken form, and students are ready to be presenting their findings and their observations and their calculations. All things they'll be super excited to present. We are also super excited. And I start with telling that last 2 years has been a real challenge, and it is an unprecedented one. And because of the pandemic, there were a lot of challenges that students had to face. It was a challenge for them to access and gather as a group, as it is a group learning. And this itself was under challenge, but students did tremendously well to organize themselves in this new age and the pandemic situation it has created. So they have done really well to bring it up to this level where they are able to present it. I really want to congratulate all the students and the faculty members for taking this far. And as you all know, this is REEV is a future, right? All the hybrid and electrical technologies as a future. And I hope from next edition onwards, we will move further beyond the technology where we have reached so far. So I want to even get into the autonomous mode as well. I think we have unlimited number of opportunities in this domain. So I wish all the students and faculty a very best wishes. Okay, and have a good one. Thanks everyone, and all the best for their presentations today. Thank you.
Thank you, sir. Sir, now I request Dean Research, Dr. Ramesh from Presidency University, to speak of it.
Very good morning to one and all, and on behalf of the university and Research and Innovation Department, It gives me immense pleasure to extend a warm welcome to all the distinguished members from SAE. And we are really thankful to SAE for giving us the opportunity to host these virtual sessions. And no, it's really great. And we feel honored and privileged to host this competition. And I take this opportunity to thank each of the faculty members and most importantly, our young, enthusiastic, very passionate students who really want to make it to the top. I think, I understand your dreams, your passion, and a great opportunity given to all of you by SAE. Hats off to them. And I wish you all a grand success. And I pray God for the success of your projects. This competition, as well as all the competitions in your future endeavors. Thank you all. And I would like to request all our honorable SAE members to give us advice and suggestions to ensure that we do contribute or we do initiate some work related to research aspects in the cutting edge technologies related to automobiles. Thank you, one and all, and I thank Dr. Uday Ravi for giving me this opportunity. And I thank our Pro Vice Chancellor, sir, as well as our Vice Chancellor. So on behalf of them, I once again welcome all the members of SAE and wish you all the very best. Thank you.
Thank you so much, sir. Next, we have Dr. Jairam Siva, known as Siva. Dr. Siva is of the College of Engineering, Gildi, Madras, Tamil Nadu. Received his PhD in structural mechanics from the Texas Tech University, and thereafter started working at General Motors. Flint relationship between Flint, Michigan, USA. He is currently Director, Technical Liaison and Oversight for the relationship between General Motors and Tata Consultancy Services, overseeing the operations between GM and TCS at Bangalore. With a career spanning over 35 years, Dr. Siva has held various positions at GM in technical and managerial capacities. Dr. Siva has guided many key technical decisions for future products related to engine design, analysis, and design processes, and production issues for GM engines. He has a patent records of invention and has several prestigious awards at GM, besides authoring several papers. Dr. Siva loves soccer and enjoys traveling. So Dr. Jairam Sivakumar will be talking to us about the future of EV technology. Over to you, sir.
Okay, can you guys hear me?
Yes, perfect.
Yes.
Can hear you.
Can you see my screen?
Yes,
Yes.
sir.
Yes, Sivan, I can see your screen.
Is it blue?
Yes.
Yes.
Jeez, I have a problem with my laptop. I got to stop.
Oh, I see.
No, I think that was basically checking. Can you hear the music?
No. No, we are
Yeah.
not. Yeah.
How do I get the music on?
Yeah. If
Audio
you
and,
can hear,
audio
please
and
be able
video.
to hear.
So you can go to audio and video there, sir, on the top. Just next to the view on the top menu of the WebEx. Sir, on the top, so file edit view.
Okay, hold on. Huh. You can teach old dog new tricks.
So in that WebEx on the top, you can
Okay,
see
on the
audio and
WebEx,
video. Able to see that? Yeah. Now we can.
where do I?
Fifth tab from the left. Slightly above that.
Above
File,
that?
edit, share, view, audio, video. In the WebEx screen, Shiva. If
So you can unshare, sir. Can I request
can
unshare your screen and go to the top. Unshare on the top, you see file, edit, share, view, audio and video on the top.
I don't see that. Okay. So I stopped. You can see my screen, right? I'm not sharing. So
yeah, on the
I
top
can.
side, file, edit, share, view, audio, video. You're not able to see on the top.
I don't see. Okay. Looks like my ignorance is exhibited a lot. So we'll stop at that point. So we'll play without the music and assuming some nice drums behind, on the background.
Some audio is coming. Yeah, finish this.
Okay. Geez. So, so you were able to see our fuel cell being assembled without the music, I guess. So this is a very old video clip, probably 5 years old. The only reason I brought this up and put it, I think Venki talked about collaboration, and you saw how the whole thing was collaborated, and the whole thing was built probably in 2 minutes on the video. So, I want the students to look at it and work in the same fashion with seamlessly without any issues or bickering or, working together as a team. So this fuel cells, we are doing it for buses and also for military vehicles. It's being worked out. Basically, they could enable stealth in the army vehicles so that it cannot be detected by a radar or a sonar. It produces close to 2 gallons of water per hour. So on a desert, it is much easier. You get water free. and the range is around 300 to 400 miles without recharging. And if left alone, it can power a hospital in the middle of nowhere. So this is a part of our future for taking care of energy issues, and then having a zero emission policy. Um, so today I just want to touch upon. Yeah, I'm clear, right? You guys can hear me?
Yes.
Yep. Very loud
Okay.
and clear.
So today I'm going to talk about the role of virtual in the future of electrification. And I guarantee you and I promise you that there are no differential equations. I can't do them anymore. Used to do that long time ago. So no high funda, just showing what the world is going to see and where we are headed to, and where as students and researchers and faculty and industry, what our responsibilities are to move ahead in the future. So a brief agenda, I'm going to talk about GM's vision, and I'm going to call what is meant by virtual, and I'm going to show you a few examples at a very high level as to what we do, and talk about challenges in the design of electric vehicles, talk about unknowns on the road to electrification, and then summarize. Shouldn't take very long. Okay, GM's vision of the future is all electric, and we are committed to zero crashes. That means we save lives, zero emissions, so that our children can inherit a healthier planet, and zero congestion, so our customers get a precious commodity of time. And especially in Bangalore, imagine being stuck when there is zero congestion. I'm waiting for that day to come, and we will get plenty of time. So these 000 is our ultimate vision, which was done several years ago, and we are working towards that. So at least there will be 30 new electric vehicles by 2025. That is the goal, and we are very much into that vision and goal. So looking ahead, General Motors plans to become carbon neutral in its global products and operations by 2040. When we say carbon neutral, what we mean by is the output of carbon dioxide is made neutral. You are not adding anything to the system so that you mess up the global warming or the climate change. So we also aspire to eliminate tailpipe emissions from our light duty vehicles by 2035. And you saw our fuel cell in operation. We are doing it for Navistar, for the Class 8 heavy duty trucks, and we had some in buses in Seattle, if I remember right. And there is a fleet of fuel cells running all over US with hydrogen fuel stations. So this is all our commitment for the futures for being very energy efficient. So we got many exciting electric products and concepts, and Ultium is our basic platform, or the platform which we use. It's very revolutionary. It's a very flexible battery architecture. It will take different vehicle types. So it produces outstanding power and range and performance. So you could go anywhere from 6 to 24 modules. These can be placed vertically. We call them the toast, or horizontally called the pancake version. So based on the number of modules, then you have the type of vehicle we use, and it provides a very thrilling driving experience, and it allows us to be charged, and it offers the range which we want to hit the road with confidence. And also this Ultium architecture being at the bottom, and it provides almost nearly 50-50 weight distribution of the vehicle, and it lowers the center of gravity, which results in a vehicle that is much sporty, responsive, and allows for very spirited driving. So I want to show you some of the products. So the GMC Hummer Eevee on the topmost corner was launched in 2021. It's almost 1,000 horsepower, if I remember right, and costs around 100,000 US dollars. And very limited are being done, but there is a huge request in the market. And below that, you see the Cadillac Lyric. It's launched just recently. It's one of our what do you call a flagship, which is a luxury model. It's also costs around say $60,000 to $80,000, having a range of somewhere around 360 or 380 miles. We launched the Chevy Bolt on the top in 2021, and it had some issues about thermal propagation. I will talk about it towards this thing. It's all taken care of. It's a learning process, so it's all taken care of by LG. And so we are selling a lot of Chevy Bolts. And on the bottom you see Bright Drop. Basically, it's a delivery truck. It has got, the pallets which are done electrically, no more manual stuff. It's a lot more safer, and you can get your stuff in and out, and delivery is made much more easier. And this vehicle was launched in 21 last year, and the development time for that was less than 2 years. Just the total development was around 1.5, I am told. And there was a lot of virtual activity which went into it. And I will talk about that shortly. And on the right side, you see Cruise Origin. It's planned for release in 2022. It's an autonomous vehicle. It's self-driven. It's all electric, and it is a shared vehicle. And it's being tried in San Francisco, and they're going to try it in Dubai this summer. And once it's been, the concept is done and tested, it will be out on the roads pretty soon in major cities in the US. And on the top, you see the cell manufacturing facility in Lordstown, Ohio. It's a joint venture with LG. It has a capacity of 30 gigawatt hours per year. And originally, they were producing trucks in 2017, 2018. And now this is providing jobs and, manufacturing a lot of batteries for our future products. And what you see in the last one is the Cadillac Vtol. It's a craft, it's a concept drone. It is for intracity autonomous vehicle. So you can just, like a helipad, you come on the top and you get down, and it's all totally self-driven. And I think once again, this will be a must and a plus for Bangalore when you go from airport to here. I know we have some helicopter rides, and very soon, in a few years, you will see one of those hovering based on how mobility folks are able to push things like this. So it is very clear our vision and products show our commitment to an all-electric future. And you guys are a part as students and researchers and fellow industrial colleagues. And this is where the world is headed to. If you look at this graph, I just want to show the projections of how quickly we get to electric vehicles. If you look at International Energy Agency, they talk about, say, 55% of hybrids, 20% of battery electric vehicles, whereas Center for Automotive Research is claiming 70 ICE and 10 on BEV. The IHS market, the S&P company, which says 70% will be hybrids, 20 will be ICE, and 10 will be BEV. So there is a large variation in the projection of the electric vehicles by 2030, which you see it goes from 30 to 80. But if you poll the executives and then talk to them, they are somewhere in the middle. The average comes out to somewhere around 52 is what they are predicting by 2032, the new vehicles which will be bought by the customers. So if you look at India, the graph shows from 21 through 30, the number of vehicles, the type of vehicles sold, and the green one are the two-wheelers, the cyan or the light blue are the private cars, the black ones are commercials, and the light green are the three-wheelers. So by the mere size of the bar, you can tell that we are still more two-wheeler centric for travel within the city for mobility. But even if this is off, the spread on the blue dotted line is around 26 million vehicles, and the spread in the bottom, which is 40% less, is around 14 million vehicles. So this will be the spread. Whether we do two-wheelers or cars or commercial buses, electric, by 2030, this is a huge challenge for us, and we need to get our technology right. So if you look at this bar graph, you look from 2018 to 2021, the passenger cars, this is India market, the dent of BEVs is only 0.5% of the vehicles sold. But if you look at 2018 to 2021, 0.04 to 0.4, it's number wise, it's when you look at the curve, it is a lot more nonlinear and exponential, and this is going to take a hockey stick and it's going to move up vertically up. So India has got lot more potential, and you see government getting in and pitching in, and all the world market coming in. So today, 2020, it's a 2-year-old data. The India electric vehicle market is 5.47 billion. By 2026, US expected it to be around 17 billion US dollars. This is a compounded value of approximately 23% increase on a year-to-year basis. So this is where India lies based on projection by the industry. So to level set, what is meant by virtual? By virtual, we mean use of any physics-based computer model to predict the performance of a component, subsystem, or a system. And this could start from hand calculation on a piece of paper, and then or running a humongous job on the uh, big high computing systems running for several days or even weeks. So the range goes from synthesis all the way to confirmation models. So we can do from 5 minutes to 2 weeks of analysis on a particular component or a subsystem. So all the assumptions are known. We look at it, we know the capability for each of this, and then we figure out how it is to be done much before the hardware is built. That is the whole idea of doing virtual. So we are in the timeline, we are moving to the left, we are reducing the time to architect a particular vehicle. So we execute a wide range of virtual models, and I want to show you a few of them. Before we go, what is the rationale behind, where does analysis come into picture to achieve this vision? So if you have a new concept, you do the architectural level analysis first. So at this point, you don't have high funda computers or software. You have very synthesis tools, and look at the concepts. You have best practices, you use them, you have the thumb rules, and then you have the experts, a little bit of opinion, you do all that, and then you go to the CAD or get the design done. So once you get the design done, you do the rapid analysis, and the arrow which you see in light or dark yellow, you go through several iterations of that. So that is the best time to clean up your design virtually. And once you are done, you come down for virtual validation using high fidelity models. And this is a virtual dyno. Still, at this point, there is no test. There is no alpha vehicle. There is no beta vehicle. So you are still playing. I shouldn't say playing. You are working on the computer and generating a virtual model. So then you go ahead on a loop. You find something on virtual. You go back to the design, clean up the process. You iterate till you are comfortable that you meet all the requirements, and then you do one hardware validation, because we would like to see how the car drives or how the engine performs, how the system works. So you do a final hardware validation. After the validation, you have a problem, you understand, you go back to design, and you go through this loop. This is the way most of us work in the industry, but we have an emphasis. I can say we coined this several years ago, and GM is one of the early adopters of virtual, development of vehicles. So this is a structural simulation. On the left, you see stresses in a car body hitting a pothole. Okay, hitting a pothole is very common in Michigan. The roads are not that great, and um, also in Bangalore, you will see if you hit a curb, you will know either you screwed up your control arm or your tie bar or whatever. You know, your alignment will be gone, your tire is gone. So all these load cases are done virtually. You don't need to try it on the roads. So we make sure that we cover majority of these load cases. So that is the stress pattern you see when you hit a pothole. On the right side, you see deformation of a battery pack due to abuse jacking. So whenever you have a flat tire, so you want to change the tire, it happens at the inopportune time. And so what you do is you pull your jack and then you put them on, and there are specified locations which you are supposed to use them. 90% of the folks do not use it. So that is why we do this abuse jacking, so that if you do that, is your enclosure of the battery pack and the bottom of the vehicle, do you screw up the battery pack? And a similar thing we do on ice is on the oil pan. So we do this. We also do abuse, and if you run through chunks of ice in the Western countries in the winter time, are you going to have road load abuse and all that? So we look into all structural aspects. We look into fatigue life. We do dynamic response. We look at frequencies. We look at noise. We look at umpty number of things. So then the next, I just want to show CFD. CFD used to be a hotshot analysis at one time, but we do CFD for all kinds of fluid and thermal problems. And what you see on the left is a arrow wake at high speed. So when you have wake, basically you increase drag, you end up screwing up emissions. You have problem with miles per hour or fuel economy, and this is more important in sports and racing, wherein your timing of 0-60 is affected due to wake, and it causes turbulence in the system. And wake also causes on the tire, you have turbulence. All this are modeled extremely carefully for different conditions, and we minimize turbulence and wake. And on the right side, you see we run a coolant flow on the battery pack and make sure that the battery pack does not heat up to the point wherein we have issues. I have a couple of slides in the back to talk about what happens when your battery packs get heated beyond what you can allow. So these analysis, we are able to predict flow, drag, heat transfer, temperatures, and temperatures due to stresses and so on. You know, the other one, GM is big on safety. Every car manufacturer is big on safety. There is a consortium. All of us work together on this. What you see is this is not a test. This is actually a analysis and nice animation being done. When there is a side impact and collision, you see what happens to the vehicle, and then what is the effect of deploying the airbag. So let me run it one more time. And these are dummies, and these dummies are instrumented analytically so that we know the displacements, deformations, and all the important variables and parameters of the dummies. And then we modify and even give suggestions to the airbag manufacturer to how to deploy the airbag, where and to produce, to place them, and so on. So we also define the crush zone, we do the deployment. So the next one I want to talk about is this is human body modeling. When you have two vehicles have an impact, vehicle to vehicle impact. On the left side, you have a belted passenger, and on the right side, you have the unbelted passenger. And I want you to take a look at how the dummies move. See, this dummy on the right is coming out of the chair, and look at the neck and see the amount of stresses that comes out on the neck. And these fractures are pretty serious and fatal in most cases. So this determines and tells you how important the use of seat belt is. So we do all kinds of human body modeling, and GM belongs to the consortium, and we basically share human body models, and then it's used. There is a 95 percentile, 5 percentile, different kinds. They model the joints, they model the muscles, and it is amazing. It is a science by itself. So the message on this slide and on this my 20-minute conversation is, if you are not buckling up, I want you to buckle up and tell your friends to buckle up. And when you drive, do not start the car till your loved ones, your friends are buckled, not on the front, on the rear also. So everyone needs to be buckled to be safe. So we also do electrochemistry at the cell level. These are all 3D CFD analysis, and there are 2D models. It models the cathode, anode, and the electrolytes, and then does the transfer of lithium transport, and we can model charging and intercalation of these lithium molecules, and it is shown on the right side. It's a, to me, it is a pretty picture and animation, but in the eyes of an electrochemist, these tell 1,000 things for us to modify how to have the chemistry of the battery, and how we transfer, how the heat is generated in the cell. So we do a whole bunch of analysis. I'm not going to go through all of them. I'm going to just highlight, and we size the propulsion for the vehicle. The second one, we optimize the shape of the cell, and we also do a lot of testing, being new to us, and a couple of our friends um, in Bangalore at TCS facility, they test cells for us, and we do lithium plating limits at the cell level. We do DC fast charging limits at the pack level. We do fast charge at the 3D CFD pack level. We also look at 1D concepts as well as 3D concepts on these. We also model the thermal runaways propagation. It's a key design challenge. See, once you have the enclosure, if you have a pouch cell or even a cylindrical cell, let's talk about the pouch. These kind of swell due to heat and then put pressure on each other. And then this pressure is like a sound wave. It pushes the actually it swells up the enclosure, and if you don't vent it properly, it's just going to blast. And before this happens, the heat generation catch gives the fire we call as a thermal incident, and this catches up so fast that it's few milliseconds, everything goes into fire. So this is a serious problem which all manufacturers, including the cell manufacturers, are working, and it is a work in progress. And there are a lot of standards coming in. We test this. More than testing, we analytically check all this and put the best solution, and then we test it later. So that is a big time work. We do a lot of battery structural and sealing and crash analysis. What we do for ICE vehicles, same concepts of structural work. We do a lot of cabin heating and cooling. I'll talk about that one more time. And on drive units, there are a lot of electromagnetic work, lubrication, thermal, dynamic, NVH. In the good old days, if you do a static analysis on a cantilever beam, we used to be kings. And then we slowly graduated to thermal analysis. Then we did noise. Then slowly we improved to conjugate heat transfer. Then we did 3D CFD. So the analysis realm has moved. I used to joke, I used to have computer cards in my hand, and then we used to load it on IBM. If you drop that, and you are in big trouble, and then we need to look line by line and put it back. We used to score a line on the top so that if you drop it down, you just put them together looking at the mark and then go and check back. But you guys are pretty you are able to do. You are talking about Python, C++, all kinds of you know um, TKC, TL coding. Um, so it's amazing as to what you guys do. But what is happening now is, I think Venki and Muni talked about it in the beginning, that no longer you are a mechanical engineer. You need to know all of this, and you need to exercise this virtually to get things done. And we also do vehicle level with integrated controls, and that is a big thing. So I want to show this schematic wherein we have system and subsystem models on the vehicle. Basically, these are optimized models, and these include the drive cycles. This have the environment. This talks about the driver demand. Then we have the batteries and the motors, all the transmission components. Then we have the cooling, we have the HVAC, then we have the cabin. Everything is modeled, and these are plan models. And then we add that with the virtual calibration, and we also added the embedded controls. And instead of testing it on the hill bench, now we are moving to the SIL, software in loop. From software in loop, we go to driver in loop, vehicle in loop. And so everything, whatever you calibrate on the road, we can calibrate on the software much before the hardware is built. That is where the power of the virtual thing is done. This is where the controls engineer and the mechanical engineers work together, and there is a software component to it, and there is the what do you call the we are into software defined vehicles. There are a lot of infotainment aspects, and all these are combined together, and we work together upfront. and I don't think the audio works, but what you see here is a simulation of a vehicle, and what you see is the dashboard. This is not your dashboard on the vehicle. This is the dashboard on the computer screen. So we can simulate any drive cycle, and this is a multi-cycle test. Basically, this test, if I recall, this is depletion of a battery almost to zero, and wherein you can look at the various components or the variables, the battery temperature in the first, look at the motor power, you look at the speedometer, you look at the range, you look at the tach, you look at the oil temperature for cooling. So then you can modify your software and you can calibrate, you can refine all of this until you get to what you want. So everything is done virtually, and once you are satisfied, then it goes into the hardware. And this is why we call it, it's a great example of what we call as a digital twin, um, as a virtual model. So if you look at ICE engines and if you look at electric vehicles, the simulation tools, the Venn diagram shows the vehicle level. Most of them are common software where we do the structural crash, ride and handling, the human body, the sill, the NVH, the 12 volt, which takes care of your lighting and other activities in the car. So these are pretty much common. But in the ICE, we have combustion, after treatment, and fuel injection. These are specialized software. So on the EV, we have the same thing. We have the electrochemistry, the electromagnetics, the high voltage. There is a huge group of power electronics people, and they are the core of the analysis in making this happen. So all these guys have the right software. We work with the suppliers. We cannot do it alone. So this is done with the suppliers, with the software guys, and this is an evolving, um, you know, industry, if you will, on the virtual side. So these are more unique, and each OEM has their own style of doing it. And we are committed to doing 100% virtual and only test in the final version. So when I say we have challenges, what we have decided is we are going to cut our development time into half, and we are also going to reduce the hardware completely, or reduce to the point wherein we will not spend any for protos. So that puts a lot of, I shouldn't say pressure, that gives us the challenge to do all this virtually. And this, we have a lot of challenges. So early we have the VTS, or the technical specifications. So we have the range defined, we have the 0 to 60 defined, we have the top speed defined, and then we all synthesize using models. Then we know what battery capacity do you need, and then once you decide that, then you go to the motor design, how much of torque it has to transmit, and then look at gear ratios, and then work on power electronics. And all this are done on vehicle level system models, and I don't even claim to know how these folks do it. It's phenomenal that they put all this together upfront. They are able to drive this virtually to define the propulsion technology for the vehicle. So this is done very early in the program, and then from there these are improved, and they polish each and every aspect of this, and then component level they go and improve. So what are the challenges involved? So the battery thermal is a key challenge. So what happens is you have a very sweet spot wherein your battery operates efficiently, the lithium ion batteries, and you see in the graph it goes from 20 to 35 degrees. Below that, it's the electrochemistry is sluggish, and you cross 35, there is degradation of the battery. So you need to monitor the thermal gradient on a battery pack. So you have a great cooling system which is modeled. You have a great sealing system, and you ensure good venting process, nice seal, and ensure that it is uniformly, thermal, temperature increase, so that you don't have a high gradient. And if you have, what happens, you have a thermal runaway, and basically from one cell to the other cell, and one module to the other, and fire catches up, and you know what happens. So there are standards, internationally, that if the thermal event happens, how quickly the system alerts you, and you need to be out of the vehicle in the eventuality if this happens. That is one of the requirement which is being worked out across all OEMs. And I talked about HVAC has a significant impact. So in the cold countries, the first thing we do is in the morning, you get into the car, you turn your heater on, so that you even have heated seats so that you don't freeze. So the minute you turn them on, then if you continue to drive with heated thing to your work or wherever, right there you lose 50% of your range of your electric vehicle. So if you go at 20 degrees with the HVAC off, you are still somewhere around 80 to 90%. Then the optimum shows around 75. And then you put your cooling on, once again, it's parabolic, and it comes down and it reduces efficiency. So the driving range gets reduced. So we have a lot of virtual models. We have 1D models tied to 3D CFD models. They talk back and forth, and then we adjust in such a way that the cabin is heated and cooled in a very efficient manner, purely for range. And we talked about, if you want, you know, to fill gas, you just stop by to a station and you pump gas, and this says 15 gallons of fuel is delivered in approximately 3 minutes, whereas it takes a lot of time to charge your vehicle. And then they are saying that we are 20% lower in terms of charging than the conventional gasoline. So this is a big issue, and this needs to be addressed. So these are challenges. So the other thing is, if you want to charge the battery so that you are able to move on from one spot to the other, or even at home you want to charge something, you have to charge in such a way that if you charge too fast, the lithium ions accumulate on the surface of the anode, and we call that as lithium plating. And then the lithium plating forms dendrites, and this dendrites is a pure thing for thermal runaway. So also, even if you don't form the dendrites, the high charging rates causes overheating, and then the overheating causes fire. So this is a very important aspect we work on. So we talk about all these challenges. So we listed a few. Given these challenges, and how can virtual help? So the first point is, we need vehicle level models up early in the design process. You cannot figure it out in the end. So that's why I showed you a vehicle model in the architectural stage. You ensure that the VTS are met, and then you bring in the controls and calibration, and that is taken care of. So the calibration engineer's job is not gone. He forms a part of the virtual team, and it makes his life simpler, and he can virtually calibrate what he does on the proving grounds or on the road. So everything is done virtually. Then we have the option afterwards to fine tune and optimize at the component level, and then you have a fine system. So there are unknown factors, while mobility is there. We looked at 2030 anywhere from 30 to 80% projection of the BEV vehicles. So it's going to show up, but we do not know how soon it's going to show up. So what are the factors that accelerate or slow down the adoption of EVs? So the battery cost is a very important factor. So we need to bring the cost of the battery down to make it more affordable. That is why the government is giving us enough, rebates. Okay. I'm hearing a lot of crosstalk. Is that me or? Okay.
Can I request all
Can
to
you
go
guys
on
go
mute?
on mute, please? Thank you. So one of the issues is battery cost, and that is where the battery manufacturers are working very hard to bring the cost so that it's easily affordable. Then you have stringent emissions. If future emissions on the ICE vehicles become very stringent, it makes the business case for EVs much stronger, and EVs will become reality closer than what we predict. Also, the customers have range anxiety, and they have concerns about charging times, and also to figure out where to charge. So there are a lot of apps coming in, and I remember several years ago at GMTCI, we had a lot of folks innovate, apps to figure out, to tell the public where these charging systems are, where how long does it take for you to get there, and there are apps to tell you, how soon you can get there, what is the waiting line. So the possibilities are endless for people to help in these anxiety and the range and the infrastructure, and people are developing so that people are comfortable driving these. My wife has anxiety even on uh, on ice engines. I drive to the last drop of gas, and I have stopped in the middle of the road in the middle of the night with snow, and I have been in trouble many times because I know our vehicles can drive a lot more range than what people think, and I have paid the penalty. But we don't do that, and people are able to understand. We optimize the range, and you can adjust. If the range is low, we can turn off several knobs and then get to the safe spot and have your infrastructure take care of your charging. And there are political factors. There are countries which bans ice outright, and I think Norway was the first one to do it in 2025, and I think France or Germany, I can't remember, in 2030 they said no more ice engines. So once it is done, this is kind of, it's like a pandemic. It goes all over the world. So US will adapt, China will adapt, rest of the world will adapt, and then then it will be all EVs. So then the gas price, if the gas price goes down, then the EVs, it will take long time. But if the gas price goes up, people will go for EVs, and the adoption is quick. So the question is, if it's not when we will get there, ICE and EVs will coexist and for some time to come through, and we need to know when we are getting there. So in summary, I'm going to let you that we are committed to an all-electric future, and you see every day OEMs declaring. Volkswagen had declared before. Toyota recently declared that they are going from, they were big on hybrids. they're pushing electric vehicles now. So all, you will see a lot more electric vehicles on the market, and virtual will play a key role in the future of electrification, especially at GM. And we just talked about the anxieties, and basically we will get there, but the question is when. So we talked about all of this, but the question is, it's a student body out here, and you are here on virtual. I want you guys to try as much as possible on virtual, remove all your kinks, and then learn, so that when you build your REEV vehicle, you have very less problems and issues. So the more you work virtual, you are able to handle. So you have all your volunteers helping you out on various aspects, and virtual is one of them. And any help needed, please let us know. And I thank you all for listening to the few slides I had. And I thank for the opportunity to talk to you. Anytime I talk with students, I get energized. And unfortunately, I am not in the campus. Whenever I'm in the campus, I'm always a few years I get younger, and I should visit Presidency and Amrita and the rest of the places. And instead of 10, we are hoping for more hundreds of vehicles competing on REEVs. Thank Venki, Muniratnam, Girish, Dr. Ramesh, all the volunteers of SAE, and all the students on opening up this REEV. And anything we can do in terms of helping, do not hesitate, and we will do our best. I do appreciate the opportunity, and we can discuss and have a few questions. The good, difficult ones, I'll pass it on to Rakesh and CP and Vijay around there. Okay. Oh, I forgot to show you this, and this is our Hummer doing donuts on Michigan ice. And this is not suggested to be done, but this is shown so that um, a huge vehicle of this magnitude and size, we can still maneuver and be stable on the ice and do this fun-loving activity. And doing donuts, if you do many of these, you need to replace your tires, and your drivetrain has to be checked. But but it is fun to do that. And I want to thank Radu, my colleague, and he is my evil twin in many ways. He is the guy who does the things well, and I'm the evil guy. And all the slides which I presented were basically his. He just gave it to me, and he's vacationing somewhere in Michigan, and he told me use these slides. And I was fortunate to use most of his slides at this time. So I just want to thank Radu for giving his slides to be shared with the student community and with the faculty out there. Thanks a lot. Okay.
Thank you, sir. Thank you, sir.
Thank you.
I would now request students, to join the other links. So you can join in like next 5 to 10 minutes. The team is working on the links now. So your session should be starting in another 5 to 10 minutes. And I would request Mr. Rakesh Bidre to give the vote of thanks. Okay. Yes.
Students, I'm sure you would have goosebumps, right? Seeing the content of last 30 minutes on how EV technology is going to pave the future in mobility. And Dr. Jayaraman Shivkumar fondly called as Shiva. Right, he is breathing that technology for, I would say, many decades, right, and represents the technology itself. So I want to take this opportunity to, say thank you to Dr. Shiva. I think Saturday morning is a precious time after a long work week, right? And thank you, sir. And I'm sure, under your guidance and support, we will surely become a oak tree. And with that, I wish all the students and special thanks to all the software partners, right? Whether it is MathWorks, ANSYS, the DASO, right, ATS, and many other software partners who are making this virtual easy for the industry as well as for the students. So thank you to them as well.
Hey, thank you, Rakesh. Good luck, students.
So I would now request the students to log off from this link, and they can start joining the other links which was sent to them.
Hari.